This is the very first graph that we are taught in class, and this is using the following interval. Using this graph, we can find the slope of secant. The line of secant is represented by PQ, and the line of tangent is represented by the line P. The distance between the secant and the tangent can be seen as h. And this is how we find the slope of secant using the slope of tangent, where I move the graph of secant closer and closer to the graph of the tangent by moving its x value so that the distance of h of the graph of secant and the graph of tangent approaches 0, as you can see. And we can apply this method once again to the preceding interval. However, for preceding interval, the graph of the tangent is on the right, and since it's preceding, the graph of the secant will approach the graph of tangent from the left. The distance h is once again the distance between the graph of the secant and the graph of tangent. Here we can see that the secant is moving closer and closer to the tangent, but it will never be the same graph as the tangent. Their distance will approach 0, and since this is a preceding interval, h should be lesser than 0. And hence it will increase and increase and increase until it approaches 0. To find the formula, we can use the usual average rate of change formula, which is y2 minus y1 over x2 minus x1. In this case, the x1 and y1 is represented by a and fa, while the x2 is a plus h and the y2 is fa plus h. And when we do it with the ARC formula, it forms this: fa plus h minus fa over a plus h minus a. And since there's two a's here, we can remove both a's, since one is minus and one is positive, to form the exact same equation like the following interval. The limit can be written as lim h approaching 0. This is because h will continue to increase until it approaches 0, according to the preceding interval. Since the definition of lim x approaching a, fx equals to L, means that fx can be made arbitrarily close to L, but by choosing some x near a, but not a. The definition can be applied to the preceding and following interval as h approaches 0, and hence we can write the final formula as limit h approaches 0, fa plus h minus fa over h. Hence, we can say that the distance between the two x values of the tangent and the secant will get smaller and smaller, in which by preceding it will keep on increasing as it approaches 0, since h is smaller than 0. It can never reach 0 where it becomes the exact same as the tangent line, but it will be very close to it.